Hey class, Mr. Henry here with another video lesson. Today's video lesson is on factoring trinomials, which is really the opposite of a skill that we have done before. So before we get into factoring trinomials, I'd like to do a bit of a review. Here are some questions where I'm asking you to multiply binomials. So I want you guys to pause the video and see what you can do here. And then once you are done, hit play and I'll put up the answers and we'll move on from there. All right, now pause the video. All right, so to go back to when we were multiplying binomials before, the trick was that everything in our first binomial had to get multiplied by everything in the second one. So that involved multiplying four different things. So let's do this first one here together. So I've got a plus 3 times a plus 2. I am multiplying first the a's. So a times a, which gives me a squared. This 2 also needs to get multiplied by the a, so I end up with 2a. Now I'm multiplying both things by the 3. So 3 times a, which gives me 3a, and the 3 times the 2, which gives me 6. Pretty much done here. The last thing we need to do is just add these two like terms together. 2a and 3a added together gives us 5a. So our final answer, we have a squared plus 5a plus 6. Now here are the answers to the other three, and I want to pay particular attention to these values that you see highlighted here. So we see the values in yellow, and I just want to think about where these numbers come from. So this 5, if we look at the binomials before, we had a plus 3 and a plus 2. So the numbers were 3 and 2, and we ended up with 5. When the numbers were negative 5 and 2, we ended up with negative 3. When the numbers were 4 and negative 3, we ended up with just positive 1. And when the numbers were negative 7 and negative 2, the number was negative 9. So you might have noticed there that really that is just the sum or the addition of the two numbers in the binomial. So 3 plus 2 gives us 5, negative 5 plus 2 gives us negative 3, 4 plus negative 3 gives us that 1, and the negative 7 plus negative 2, which gives us negative 9. Now let's take a look at what's happening in the green. So in the green, we see when the numbers were 3 and 2, we ended up with 6. When they were negative 5 and 2, we ended up with negative 10. When the numbers were 4 and negative 3, ended up with negative 12. And when they were negative 7 and negative 2, we ended up with positive 14. So maybe you noticed that these last numbers here, or as we'd called it before, the C value, really just comes from the product of the two numbers in the binomials. So really we're seeing two things. We're seeing that this value comes from the sum or the addition of the two numbers, and the last value here, the C value, is just coming from the product or the multiplication of those values. To sum that up, we are just looking for a sum and a product. So the two numbers have to add to this B value. And then the numbers have to multiply to this C value, or give us a product of the C value. Now you may be wondering why this is useful. It's useful because if we know that the numbers add to B but multiply to C, that's going to help us work backwards and figure out what our factored trinomial is. So we should be able to take something like what we have up there and turn it into a factored quadratic, just like this. Why is that useful? Well, we've learned before that if you have something like this, you can easily graph it because you'll know where the x-intercepts are. Let's take a look at a couple examples. So starting with example A here, I've got x squared plus 7x plus 12. And I'm going to just focus in on these numbers for a second, the 7 and the 12. We are looking for two numbers that give us a sum of 7 and a product of 12. So in other words, the two numbers, when I multiply them, when I add them, I'm going to get 7, and when I multiply them, I'm going to get 12. Now, there should only be one possible combination for that. And for this example, you might notice that the numbers are probably 3 and 4, because 3 plus 4 gives us 7, and 3 times 4 gives us 12. There weren't a whole lot of options for this one, but it's often easy to think of this multiplication first, right? There were only a set number of things that actually multiplied to the 12, right? 4 and 3, 6 and 2, or 1 and 12. So it has to be one of those combinations. And only one of those combinations adds to 7. So if I'm trying to factor this, then this is all equal to x plus 3 and x plus 4. If I really wanted to check my answer, I could actually just multiply this out again. Multiply x times 4, the 3 times x, and the 3 times 4. We should be able to get back what we started with. Let's take a look at the second example. So in this second example, I'm looking for two numbers that add to give me -3, and they multiply to give me -10. So that tells me that, well, if I know that they multiply to give me a negative value, then one and only one of those numbers is going to be a negative number. So let's just quickly think about what numbers multiply to 10. It's got to be either 1 and 10, one of those numbers being negative, or 2 and 5, and one of those numbers being negative. So if I think of the possible combinations, 1 and 10, there's no way I'm going to get -3. But with 2 and 5, in fact, if I have a +2 and a -5, and I add those two numbers together, I would get that -3. So this tells me that when I factor this, I'm going to end up with a plus 2 and a minus 5. So again, these two numbers here, the +2 and the -5, they have to add to give me this value, the -3, and they're going to multiply to give me this value, -10. Here are a couple examples. I want you guys to pause the video now and try these two on your own and see what you can do. Remember, you are looking for two numbers that multiply to give us this last number, but they will add to give us the b value. Okay, in this first question, we are looking for something that multiplies to give us +16 and adds to -8. Now, maybe that seemed a little weird at first, but if something multiplies to be positive, but when I add them, I end up with something negative, then that tells me that I really have two negative numbers. Right, because a negative number times a negative number would give me a positive, but when I add them, I would still have something that's negative. If you're thinking of numbers that multiply to 16, 4 and 4, or 1 and 16, or 8 and 2, here the option that gives us 8 is -4 and -4. So the numbers here would actually be -4 and -4. Which means that my expression would factor to something like y minus 4, y minus 4. I shouldn't write the same thing twice. Really, this is just y minus 4 squared. In this other question, this was a pretty easy one. We did multiply to a positive number, like 9, and add to a negative number, negative 10. So again, we're going to have a positive number, or sorry, we're going to have two negative numbers here because a negative times a negative will give us a positive. You may have found that the numbers here are negative 1 and negative 9. Right, the only other possibility to multiply to 9 would have been 3 and 3, and negative 3 and negative 3 would have given me negative 6. Here I have negative 10, so the other option is 1 and 9. So my numbers are negative 1 and negative 9. So when I factor this, I'm going to end up with a minus 1 and a minus 9. Let's look at a couple more. These ones look a bit messy, but they're really not any more complicated than the ones we've just seen. So again, we are looking for something that multiplies to give us this last term and adds to give us this term here. Remember, in any of the previous questions, there was always this x. So we can kind of ignore the x in this term. The only thing that's new is the y. And over here we have a y squared. So we are looking for two numbers that multiply to give us this negative 15y squared, and they will add to give us the negative 2y. So both of these terms are just going to have a y in them. The only difference here is the variable, but finding the numbers, we do the exact same thing. We could almost even ignore the y for now. What numbers multiply to give us negative 15? Well, one of them is going to have to be positive and one of them is going to have to be negative. The only numbers that multiply to negative 15 would be, or to multiply to 15 would be 1 and 15 or 3 and 5. In this case, it's 3 and 5. Specifically, we're going to have a positive 3 and a negative 5. Right? If it were the other way around, this would have been a positive 2. But because they're multiplying to give us negative 15y squared, they both have a y in them as well. So we have positive 3y and negative 5y. So when I finish factoring this, I'm going to end up with x plus 3y and x minus 5y. Exact same thing happens in this second question. Something that multiplies to give us b squared. If it helps to think of this as 1b squared, that might make things easier. And they add to give us negative 2b. If it's multiplying to give us 1, there's only one combination of numbers that do that. It would be 1 and 1. 1 plus 1 is obviously 2, but in this case we have a negative 2. So the numbers are going to be negative 1 and negative 1. With the b, it's really going to be negative 1b and negative 1b. I'm not going to write in 1b, I'll just write negative b and negative b. So what does this look like when I factor it? It's going to be a minus b, a minus b. And just like the question we saw before, I shouldn't write this out twice. Really, this is just a minus b squared. So there you have it. Those are the very basics to factoring trinomials. Again, to recap, really the key thing that we are looking for here is two numbers that add to give us a first term or our b value, and they multiply to give us our c value.